Advanced Algebra 1 Topic 9 Review Worksheet. And I'll start on the separate sheet of paper here. You're supposed to solve these equations, and we can use whatever method you prefer. And I actually believe this guy factors 2x squared, negative 4, 7x, 2x and x, I think 4 here and a 1 here, 8x and x. If this is negative, it's all good. So factors are 2x minus 1 times the quantity x plus 4. And then we set each factor equal to 0. So 2x minus 1 equals 0. X plus 4 equals 0. And then we solve. So here we subtract 4. Here we add 1. And then we divide by 2. So the x-intercepts, the zeros, where it crosses the x-axis, all of that stuff, 1/2 negative 4. So the real solution. Okay. Number 2 is x squared minus 6x equals 11. And so x squared minus 6x minus 11 equals 0. Our first task is to set it equal to 0. Having a little puppy trouble here. It's working. It's working. Okay. I don't think this factors. I know it doesn't factor. And so we can complete the square. We can use the quadratic formula. Obviously, I don't want to complete the square. It actually wouldn't be too difficult on this one, but quadratic formula, the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2a. Okay. Then we simplify 36 plus 44. 36 plus 44 is 80. So this is 6 plus or minus the square root of 80 all over 2. And then 80 simplifies 2 times 40, 2 times 20, 2 times 10, 2 times 5. Let's see, here's 2 alike, 1 comes out, 1 disappears. Here's 2 alike, 1 comes out, 1 disappears. So this simplifies to 6 plus or minus 4. There's a square root 5 left, all over 2. And because everything is divisible by 2, the 6, the 4, and the 2, I can reduce that to 3 plus or minus 2 square root 5. Number 3, we have x squared plus 14x minus 44. 1 and 44, 2 and 22, 4 and 11. That's not going to factor. So again, opposite of b plus or minus the square root of b squared. That's 196. Yep. Minus 4 times a, which is 1, times c, which is negative 44. All over 2a. Okay. So 196 plus 44 times 4 is 372. Square root 372 all over 2. Well, this is going to be a fun one. 372, we start breaking it down. 2 times 186, which is 2 times 93, I believe. Yeah. And 93 is divisible by 3. It's 3 times 31. 31 is prime. So only thing we can take out is a 2. So I'm going to have negative 14 plus or minus 2 times the square root of 93 all over 2. Again, I can reduce everything by 2. So my final answer, negative 7 plus or minus the square root of 93. Moving right along, number 4. X squared minus 5x equals 84. First thing we have to do is set that equal to 0. So x squared minus 5x minus 84 equals 0. I believe this factors. So if it factors, it always makes our job a little bit easier. X squared would be x and x. 84, negative 84, we're trying to make negative 5x. 84 is divisible by 12 and in 7 times. So this, I get 12x, I get 7x. Obviously I need the 12 negative, and then everything works. So this factored to x minus 12 times quantity x plus 7. So then we set each factor equal to 0 and solve. So this gives me x equals 12. This gives me x equals negative 7. We have 3x, the quantity 3x minus 1 squared equals 36. And we could multiply that out, move the 36 over, use a quadratic formula and solve. Or it's already set up to take the square root of both sides. So if I take the square root of both sides, I get 3x minus 1 equals plus or minus 6. So I can do 3x minus 1 equals 6, or 3x minus 1 equals negative 6. 3x equals 7, x is 7/3. 3x equals negative 5, x is negative 5/3. And then number 6, we have 196x squared equals 121. Again, this is set up to take the square root of both sides, but I'd really rather the square root be by itself. So 121 over 196. And then I get plus or minus 11 over 14 is my answer. That's the square root of 121 is 11. The square root of 196 is 14. Okay. Number 7. We're supposed to simplify the square root of 128. So we just do the prime factorization there. That's 2 times 64. That's 2 times 32. That's 2 times 16. That's 2 times 8. That's 2 times 4. And that's 2 times 2. A lot of 2's. So here are 2 alike. 1 comes out, 1 disappears. 2 more alike, 1 comes out, 1 disappears. 2 more alike, 1 comes out, 1 disappears, and I have 1 left over. And so we multiply that out, we get 8 square root 2 as our answer. Number 8 is 3 times the square root of 2x to the 5th times the square root of 8x to the 3rd. And We've done these in class before, and I said what I like to do is just write it as one big square root. So we have 2, and then 8 is 2 times 4, which is 2 times 2. So it's 3 2's. And then we have x to the 5th and x to the 3rd, which make x to the 8th. So 2 alike, one comes out, one disappears. Those are taken care of. 2 alike, one comes out, one disappears. Those are taken care of. And remember to take the square root of an exponent, we divide it by 2. So x to the 8th becomes x to the 4th. Everything came out of the parentheses, so there is no more, or I'm sorry, everything came out of the radical, so there is no radical symbol left. There's no square root left. 6 times 2 is 12. X to the 4th would be our final answer. Number 9. Number 9 is a similar question. 2 times the square root of 6x to the 5th times the square root of 18x to the 4th. And so again, I like to just write one large square root. 6 is 2 times 3, and 18 is 2 times 9, which is 3 times 3. So that's 2 times 3 times 3. And then I have x to the 4th and x to the 5th, which make x to the 9th. So now I can start. There's a 2 here and a 2 here. One comes out, one disappears, and they get multiplied by what's already out there. There's already a 2 out there. I didn't say that on the previous problem. Here's a 3, here's a 3. One comes out, one disappears. Looks like there's a 3 left over. But then x to the 9th, remember, is x to the 8th times x. So the square root of x to the 9th is x to the 4th with an x left over. And it looks like I also had a 3 left over. So my answer is going to be 12x to the 4th times the square root of 3x. Number 10. What are the coordinates of the vertex of the graph of y equals x squared plus 2x plus 8? I know their intention was for us to complete the square on that and find the vertex by completing the square. I'm not going to do it that way because we have a better method. X equals the opposite of b over 2a, so x is negative 1. And we plug that in, we get 1 minus 2 plus 8. 1 minus 2 is negative 1 plus 8 is 7. So our vertex is at negative 1, 7, which is letter B on the review worksheet. And moving on to number 12. It says which equations have only one real solution? Select all that apply. So for letter A, they have 4x squared plus 4x plus 1 equals 4x plus 1. So when I get this set equal to 0, I'm going to subtract 4x from both sides, and I'm going to subtract 1 from both sides. And I'm going to end up with 4x squared equals 0. And I can stop there. I know that I'm going to have one solution. It's going to be a double root. X is going to equal 0. Because if I divide by 4, I get 0. And then if I take the square root of both sides, I get 0. So that has one solution. So A will be part of my answer. Okay. Letter B has 4x squared minus x minus 1. That's a trinomial. And that trinomial, don't think it'll factor, but we could throw it into the quadratic formula. And that's going to have two solutions. They may be it's going to have two solutions. Okay. C, well, I'm going to go back to B. I'm not comfortable with the way I answered that. I know it's going to have two solutions. How do we know for sure? We look at the discriminant, which is b squared minus 4ac. So 1 minus 4 times negative 1 times 4 is 1 plus 16 is 17. So there's two solutions. They're irrational, but there's two solutions. Letter C has 2x squared plus x plus 1 equals x plus 1. So again, when I subtract to get this thing equal to 0, I get 2x squared equals 0. So that is going to have one solution, right? So C also works. C will also be part of my answer. And then D is 4x squared. It looks like I made a mistake there. It's supposed to be 4x squared equals 1. I have a negative in there for some reason. I was probably thinking I was typing minus 1, but I actually wanted it to equal 1. I could divide by 4 and then take the square root of both sides. I get plus or minus 1/4, which has obviously two answers, positive 1/4 and negative 1/4. So my only answers are A and C for number 12. 13, solve the system of equations y equals x and y equals x squared minus 3x. So what I want to do is set those equal to each other, use substitution. So x squared minus 3x equals x. I'm going to subtract this x from both sides and set it equal to 0. X squared minus 4x equals 0. And then there is a greatest common factor. It is x times the quantity x minus 4 equals 0. Then I set each factor equal to 0. X equals 0 or x equals 4. And then I use the equation y equals x. So if x equals 0, y equals 0. And if x equals 4, y equals 4. So the 2 points where this line intersects this parabola are at 0, 0, and 4, 4. Okay, number 14, same type of problem, a little bit more difficult. Y equals x squared minus x plus 3, and y equals minus x plus 5. So again, I'm going to use substitution. Y equals this, so this is equal to each other. Let's see, x squared minus x plus 3 equals minus x plus 5. I'm going to add x, and I'm going to subtract 5. And I get x squared minus 2 equals 0. And I can add 2 to both sides. X squared equals 2. Take the square root of both sides. X equals plus or minus the square root of 2. And then basically to solve for y, y equals minus x plus 5. So y is going to equal the opposite of x. So if I'm looking at my answer being the square root of 2, it's going to be negative square root 2 plus 5. And if I'm looking at my answer being negative square root of 2, the opposite of that would be positive square root of 2 plus 5. So where do these two intersect? They intersect at the square root of 2, negative square root 2 plus 5, and negative square root 2, square root 2 plus 5. So that was number 14. Number 15 is that triangle. And it is a right triangle. And this is 8. This is x. This is x plus 2. So obviously we're going to use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So this is x squared plus 64 equals, remember this means x plus 2 times x plus 2. And x plus 2 times x plus 2 is x squared plus 4x plus 4. Now they were really kind to us because those x squareds are going to drop out. And I'm going to subtract 4 from both sides and get 60 equals 4x. Divide by 4, x equals 15. And it asks for what the value of x is in the right triangle below. X is 15. So that's our answer. 16, they give us 25x squared plus 70x plus c. And we're supposed to find the value of c that makes this a perfect square. Well, we got to divide by 25 first. So plus 70 over 25x. And then 70 over 25 reduces to give me a second. 14 over 5. So this is x squared plus 14 over 5x. Now this is when I take half of the coefficient. So I get 14 over 10. And then I square that. And actually I should reduce that. 14 over 10 is 7 over 5. Okay, and I square that, and that's what my value of c should be. The answer here is 49 over 25 is what c should be to make that a perfect square trinomial. Take half the coefficient of the linear term and square it. But in order to do that, the coefficient of the squared term has to be 1. That's why I divided by 25 first, reduced it, took half, reduced that, and then squared it, and got the 49 over 25. 17. So we have p of x equals negative 3x squared plus 12x plus 75. X is the number of items made. P of x is the profit. How many items will maximize the profit? Whenever we see maximize, minimize, we're thinking vertex. So the vertex is the opposite of b over 2a, which is 2. So how many items maximize the profit? X represents the number of items. So 2 items will maximize the profit. For 18, they give us 2x squared plus 3x plus 4, and it's asking for what the discriminant is, and the discriminant is b squared minus 4ac. So that's going to give us 9 minus 4 times 2 times 4, or 9 minus 32, I think. And 9 minus 32 is negative 23. So the discriminant is negative 23. And then in number 19, it asks, what does that discriminant mean? So if you recall, the discriminant is less than 0, okay, when b squared minus 4ac is less than 0, then we have two conjugate, complex, imaginary, whatever, roots, okay? So number 19, they're asking what's the nature of the roots if this is negative 23. The answer would be C. There are two conjugate, complex,